Okay, great. Welcome, everybody. My name is Jennifer Griffith, and I work at NUMOA, which is the Northeast Waste Management Officials Association. And I want to welcome everybody today to this webinar we're having on gypsum wallboard and opportunities to improve its management and increase recycling. We have had a focus on gypsum wallboard for quite a while. So NUMOA, I'm showing our brand new NUMOA website. It's just newly sort of soft launched because there's still definitely some issues with it. But I wanted, and the old website, when you had the homepage, it told you right away kind of what NUMOA was. But I will click on our mission and folks can read here at the top. So NUMOA, we're a nonprofit, nonpartisan interstate association made up of the waste programs and some other programs in the states, the environmental programs, the environmental agencies in the states of the 6 New England states and New York and New Jersey. So the state government environmental programs work together, and we focus on topics of priority, and one of the solid waste topics is definitely gypsum wallboard, and gypsum wallboard is a problematic material in the waste stream. As we heard about, we had a webinar a couple weeks ago. I encourage folks that didn't attend to view the recording of that. But we focused on sort of the issues that are created by gypsum wallboard in the waste stream, and also about some of the current recycling activities that are happening. NUMOA is here in the Northeast, and there's very limited recycling going on in this region. So we're hoping to encourage greater recycling by having these webinars. So today's webinar is focused more on solutions, hopefully. And so NUMOA, we do have an events area of the website. It's a little hard for me to explain where and how you could find the presentation and the recording. It'll show up as one of the top 3 for the time being until we hold more events, and then it'll be harder for you to find them. But we're also holding this webinar today with our sister organization, NERC. So NERC is the Northeast Recycling Council. It's 11 states, so it's the 8 NUMOA states plus Pennsylvania, Delaware, and Maryland are part of NERC. And NERC also focuses on solid waste issues and recycling. And they have an events area, and then you just come down to webinars. And here's today's webinar. And if you scroll down a little bit farther, you can find the webinar that we had on the 9th, and that has, let's see, where is it? Here we go, recordings and presentations. The recording of it and all 4 of the presentations. So I just wanted to show folks that quickly, and also to thank NERC for participating with NUMOA on this issue. So with that, I'm going to go back to the NUMOA website. Now we get a different picture. Every time you click on the homepage, you end up with a different picture. But there are a lot of resources on the NUMOA website, but navigating and that sort of thing is, you got to go in there and try to figure it out. So with that, I'm going to introduce our first presenter to talk about sort of the issues with construction and renovation projects and gypsum wallboard. So our first presenter is Michael Orbank. He works as the sustainability manager for the Northeast region at STO Building Group. In his professional role, he supports project teams with green building certifications and introduces innovative and sustainable construction practices on job sites. In his networking and advocacy roles, he co-chairs the Carbon Leadership Forum of Boston's Deconstruction and Reuse Group, where he collaborates with passionate architectural, engineering, and construction industry professionals to decarbonize the built environment, support regional deconstruction and reuse policy, and pilot much needed changes to the typical construction project. So with that, I'll turn it over to Michael. So thank you, Michael.
Thank you for that great introduction. Hello, everyone. My name is Michael Orbank. I work for the STO Building Group, representing Structure Tone in Boston, Connecticut, New Jersey, and Philadelphia. In addition, I co-chair the CLF Boston Northeast Working Group for Deconstruction and Reuse. Just so people can see the slides a little better, I will turn off my webcam just so everything can be a bit bigger. I believe the slides, as Jennifer mentioned, will be up afterwards. So let me go ahead and do that now. So currently, when looking at gypsum wallboard waste in construction, my specialty working in Structure Tone is in interiors. Just to set a baseline for knowledge, the typical turnaround time for an interior space in Boston is averaging right now about 3 to 5 years. So because of that, I can very honestly say that the interiors market is drowning in gypsum wallboard waste. Typically between demolition and construction, gypsum wallboard will account for over 40% waste, and that is including both projects that are pursuing a green building rating system such as LEED, and just kind of general projects in themselves. And as this has probably been discussed in the last webinar, one of the main problems is that when commingling waste or kind of making it all go into kind of a single source dumpster that is then sent out to be picked through and found recycled materials where it can. A lot of times when gypsum wallboard waste is thrown into this, the contamination from the fines and the breakdown of that gypsum wallboard, there's a real number on what can actually be pulled from those commingled loads to be recycled. Another problem that I'm seeing in our industry is the lack of extender producer responsibility in several different material streams, but gypsum wallboard being quite a hurdle. And looking at take-back programs that do exist right now, and a lot of the projects that are being done within the city, there's nothing that can match a lot of the requirements of, hey, you need to fill up a semi's worth of materials to be taken back. A lot of times through the ups and downs of different construction projects, I may have a ton or two here, a couple tons there, maybe half a ton, and a lot of time not being able to get all of the same manufacturer and their product to send it back. Another problem that I've been seeing is there's a lot of questions about the end of life destination of this waste. Typically with commingled loads, sending it out through a hauler, it'll be taken to a sorting facility. And while a report is given back, many times there can be several different transfers of that waste, double, triple handling. And before you know it, the report that I have that says where the final end of life destination is very much could not be where that waste ends up. When looking at LEED and different green building rating systems, a lot of times they're focusing on material health, emissions, and VOCs, but those rating systems in that industry really has quite a lag thus far on the circularity of a lot of its waste and waste materials. Lastly, something that is only recently, I would say 2022 and going forward, that has really started to kind of put fire under a lot of contractors is changing owner requirements. I've seen in the past couple months different RFIs and RFQs come through, really requesting that the contractor go above and beyond what is typically known and typically expected. Projects that aren't even going for a green building rating system, asking for 75% plus for waste diversion across the board, which right now, unless site separation and a very keen eye are taken before waste is even generated, extremely difficult, if not impossible, on interiors projects in different cities. Before I move on, I'll showcase the two photos. So the photo on the top is just kind of a typical, as the project goes on through demo, wallboard being kind of pulled off and thrown into a dumpster. And then the photo underneath that is a lot of times what it ends up turning into before being sent to its final destination. That is a photo taken from a local RCI facility, Resource Roxbury, where a lot of Boston waste goes, really showing you the breakdown materials, and some of that is gypsum wallboard in itself right there. So when looking and asking, well, why use gypsum wallboard? Are there any alternatives? There's definitely planning considerations that need to take into account. Right now, the cost of gypsum wallboard is extremely competitive for new wallboard. It's very available. Many different manufacturers have kind of flooded the market with good products that fit the exact needs of a lot of different projects. But because it's so available, is there availability for any possible commercial alternatives? Also looking at the purpose and being in construction, the risk that it could be taken from that. And then there's planning considerations. Are you going through a commercial project, or are you looking towards residential? A lot of times residential may have a lot more wiggle room than kind of the strict, not only through policy, but also through preference of the owner. As well as looking at the material properties themselves. Gypsum wallboard is typically used for a plethora of reasons, but some of the most profound are the ability for sound absorption and acoustics in a space, fire resistance. A lot of different gypsum wallboards, especially nowadays, you can have the mold tough, you can have that, but the fire code X, as they have a lot of different products, really go above and beyond to make sure that that fire resistance is inherent to the product. There's a lot of indoor air quality and volatile emissivity concerns when looking at these wallboards. And then lastly, you have to look at the material health of the product as well. Is it kind of dangerous to manufacture through installation? Are you making sure that it's a healthy material? So really, when considering alternatives, when looking at all these considerations, you really start whittling down what can actually be used. Looking at kind of a plywood or a medium density fiber board, it can have some of the strength concerns. It can have some of the IQ and VOC properties, but does it have the cost? Is it actually going to be able to perform for sound absorption? Does it even have any fire resistance? You can look at cement board, which may have some of those, but typically is a bit heavier, which is going to come with additional labor costs, additional costs for transportation. And then you can take a look at something like an acoustic panel to put on the wall. And then when really diving into that, what is the backing that is needed for that? What does the assembly look like? And more as you look at all these alternatives and considerations, you find that because we've been using gypsum wallboard for so long, because the industry has gotten so good at not only manufacturing it but installing it, it seems for the time being that it is here to stay. Knowing that gypsum wallboard, at least for the time being, is what we're going to have to deal with, I and others kind of towards more kind of sustainable construction practices have started to say, well, how do we go about making sure that this is the least wasteful process as possible? How can we make sure that we can avoid sending this directly to landfill, or heaven forbid, looking to try to incinerate it? And one of the most powerful tools in our arsenal is site separation, really moving the responsibility to the contractor. Typically, having a single dumpster commingling everything, send it out of sight, out of mind, is business as usual. But we're finding that is a very unsustainable way of doing business, especially when planning our waste. So to make sure that we achieve this site separation, we're really going to have to, in pre-construction, take a look at how are we wording and what are we binding our subcontractors to? Are we making sure that this isn't a surprise once they get on site, that, oh, hey, surprise, we're actually going to try to save as much of this gypsum wallboard as possible. We're going to separate it. It needs to be well explained, and it needs to be worded in a way that subcontractors not only have buy-in, but they're made to work through this. In addition, making sure that logistic plans and the exact route of waste is planned out beforehand. You don't want to double, triple handle waste. And then really making sure that the waste hauler has buy-in. So you can call up and say, hey, waste hauler, I have a load of gypsum wallboard. Where will you be taking this? Can you make sure that it's going to a destination that doesn't just look to landfill it? With having the field staff on site, they're the ones that are managing this waste, moving this waste. So making sure that signage, like you see in the middle photo to the side there, and an explanation of what is going into your typical receptacles being in interior construction, there's a lot of hamper use in the Boston and New Jersey markets I help oversee. But making sure that there's proper signage and oversight is very critical to buy-in. And then something that I found is that by explaining the why and explaining what you perceive as the how for making sure this gypsum wallboard is kind of processed and collected properly, there's a lot of room for innovation when it comes to field staff. They're the ones who are kind of day in, day out handling this. And there's a lot of tips and tricks that can really refine the process if you put your faith in the field staff. And lastly, kind of knowing what we can do, how do we improve the process? And it's really looking at kind of the right sizing of pickups. If I only have half a ton or a ton of gypsum wallboard, does it make sense to have a 30-yard dumpster roll up? Do I even have size for that? Really making sure that working with your waste hauler to right size what's being picked up, so you're not unnecessarily paying for more or transporting and really having those additional carbon and money costs. And then lastly, really avoiding any double handling, triple handling of waste that kind of goes against what we're looking to do by increasing efficiency. Before I move on, just taking a look at the photos, that middle photo, as I've said, is making sure that we can really label and keep as clear as possible which waste stream is going in kind of which container. If you look above that, I had said allowing for innovation. On one of my projects, the field staff went above and beyond and had some kind of larger panels that were going to waste and went right ahead and worked towards keeping even more gypsum wallboard waste within these hampers, kind of by making its own container and granting even more space. And then lastly, the photo at the bottom, when we do get rid of gypsum wallboard, knowing that really to have the proper PPE because it is so friable at times, making sure that there's no fines getting into workers' lungs and they have proper gloves. Looking at the industry from a whole, what do contractors need? When working with designers, it's critical to make sure that circular materials are being specified and that deconstruction is being kind of designed towards. It makes our lives even harder if we have to go into a space that had no kind of either end of life or disassembly design when it was first put in. The more adhesives that are smattered over the wall, the harder it is to pull things off, the harder it is to kind of start the deconstruction process to make sure that the waste we are pulling off can be properly recycled or reused. When working with haulers and recycling outlets, really collaborating so that opportunities that are there that maybe we aren't aware of or an unsophisticated contractor would not know about are really illuminated and kind of brought to light. When collaborating with manufacturers, really discussing the take-back program and looking to revamp it. In the past few months, I've talked with several gypsum wallboard manufacturers in the kind of New England area and speaking through what they currently have for take-back programs. Like I said earlier, sometimes it doesn't fit how the natural progression of demolition and different jobs in an interiors context would be. I hyperlinked both partnerships and pilots. If anyone's looking at this afterwards, there are 2 links there. Looking at partnerships, how can we partner with manufacturers to set up pipelines that might not have been there to start returning gypsum wallboard waste. The picture that you see here is a facility just outside of New York City on the Hudson, where my equivalent in the New York City office for Structure Tone is working with Certainty and Saint-Gobain to start a pipeline coming from New York City right back to their manufacturing facility to become much more circular. In the pilots in the current in the Boston area, I worked last year with a lead project that was looking to achieve much higher waste percentages than typically seen, and piloted. I helped pilot a overall site separation, including gypsum wallboard. Some of the pictures you had seen on the last slide, to see not only what is possible, but to kind of push the current idea of how do we go about actually collecting this, and how do you work with the field staff. And then lastly, when looking at policy and regulations, making sure from that perspective that gypsum wallboard waste bans are being enforced. to really kind of light a fire under contractors so we can't get out of it by commingling it and sending it out. Continuing any grant funding or incentives for innovation that savvy contractors can pick up on. A lot of times the construction time and schedule are just really ruling everything. So if we can kind of offset some of those additional costs for innovation. And then lastly, in policy, mimicking what some other municipalities across the country have done. The first comes to mind is Nashville, but really making sure that C&D, construction and demolition, waste diversion has firstly reporting mandates that every project needs to report on it, and then as that policy matures, starting to start with maybe a 50% waste diversion from landfill and slowly creeping up. As I've discussed with some of my other industry colleagues, the best way to hit a high waste diversion percentage is to either fully reuse or fully recycle. We can only do so much with commingling. We can only hope that the facilities that are going through this waste and collecting it can recycle so much. The responsibility really starts to push back on the contractor to make sure we're actually hitting these numbers and can actually work with our owners and their requirements as well as emerging policy. Lastly, I'll just share some resource and contacts. In Mass, in the greater New England area, there are a lot of market development groups that have been popping up. The Mass DP has a reduce and reuse working group where gypsum wallboard waste, among a lot of other things, are discussed. In addition, the Mass DEP has started a deconstruction working group looking at unique problems just like this. Within the industry itself, the Carbon Leadership Forum of Boston / Northeast is discussing problems such as this and through the lens of embodied carbon. In addition, the Environmental Business Council of New England has done what I think is a pretty good job of kind of going through the problem, and each year holding a C&D Material Summit where gypsum wallboard is discussed. I actually think the summit this year is this Friday. Some resources, once again, if you get this in PDF, please feel free to go to the link. RecycleWorks of Massachusetts, in collaboration with the Center for Ecotechnology, has been an amazing resource for me and other construction managers as they look to improve on their waste practices and efficiency, as well as Build Reuse, which is a national nonprofit really looking to promote building and material reuse. Lastly, I'll say if anyone is interested in this, feel free to reach out. The CLF Boston Deconstruction and Reuse Group emails us below, as well as my own down there. I welcome any questions or pilot opportunities from the industry, as this is very clearly a problem that is only getting worse going forward, and real change is needed in this industry to make sure that we can meet the challenge.
But the delta between your lists was so small, I guess
I think that is it. If anyone has any questions, I'll stop sharing my screen.
Yes, so I'm a super bad webinar host because I totally forgot at the beginning to say one key thing, which is that people should type in questions at any point during the webinar, and we'll take some questions after each presentation. But there is in your control panel for GoToWebinar a section for questions, so you can put your questions in at any point. So I don't think there are, but I will look. Let's see, in general, what percentage of C&D is composed of gypsum wallboard waste? So particularly like if it's I don't know if you mostly work on renovation projects, Michael, or if you work on actual construction or actual demolition, but maybe there's different compositions for each one.
Yeah, typically most of the market I'm serving is in interior construction. So it'll either be a site that is given over in core and shell, in which there's not going to be much gypsum wallboard waste other than kind of the clean cuts that are coming off of our carpenters going in and putting up walls. If we get a space that is demolition and construction, that is a little bit of a dance, making sure that any of the gypsum wallboard we are pulling off of these interior projects is the clean gypsum wallboard, not too much contamination, isn't spoiled with any moisture concerns or haven't been any oil concerns. In projects where it's both demolition and construction, I would say gypsum wallboard is well over 40% sometimes by weight. If it's just kind of going in, it's going to be clean cuts. It'll go down a bit, maybe 20% of the waste. But depending on kind of the size of the projects, it can get up to, I would even say something like a 60%, depending on the wall systems that have been put in and what we're looking to take out.
Okay, thank you. How about just a little more detail on this 3 to 5 year cycle? So are you saying that means interior office space or a lab or whatever is getting redone every 3 to 5 years? And is that expected to become less frequent with the economy, or or with COVID? What happened here?
Yeah, I mean, currently the 3 to 5 years, the last I heard, I think the BPD, the Boston Public Development Authority, put that number out a little while ago, and it stayed consistent even a bit past COVID. There are always going to be concerns of are people coming back kind of post pandemic, but for what I've seen, and I think what other interior construction firms have seen, is it's not slowing down that much. And the 3 to 5 years really is typical. Something of a heartbreak is that actually post-pandemic, kind of coming back in the past few years, some interior sites have actually been a bit abandoned as the pandemic came in. Projects that were just finishing up, say in February 2020, March 2020, everyone got out of the office, and now some projects are looking to come in to spaces that hadn't ever really been used. So there's new fixtures, new furniture, everything that as the space goes from owner to owner, they don't want that anymore. It doesn't fit their design criteria, it doesn't fit what they're looking for to fit the space out. So that comes with the great sadness, but great opportunity for reuse and deconstruction to make sure that we can be the least wasteful we can be and really optimize where is all this material going through. But sadly, 3 to 5 years is still what it's looking like.
Okay, and then there's a couple people are really wanting to know a little bit more about extended producer responsibility. This also came up in the prior webinar as a thought for making some change. So do you have any examples of gypsum wallboard take back, or how do you think that extended producer responsibility would work for this particular product?
Sure, yeah. Classic examples of extended producer responsibility that I think are becoming more robust even as time goes on would be the something like flooring manufacturers and I think ceiling tile manufacturers doing a real good job at really wanting their product back, offering solutions, slowly starting to kind of break down those hurdles. However, when it comes to gypsum wallboard, there's been a bit of a hesitancy really to take that product back, to work with outlets to actually set up these pipelines. I'm not a manufacturer. I don't claim to speak for them. But what I've heard is there's concerns of, are we taking back kind of our product? Are we making sure that we can actually even take it back and put it into a formulation that can be put into a new product that can become more circular? So right now, there's, as I had shown in the presentation, there are some pilots, there are some programs being done. Like I said, Certainty and Syncopate and the New York City market have started a pilot with Structure Tone New York. I'm hoping to work with a manufacturer too up in Portsmouth. There's a very large gypsum wallboard manufacturer, that National Gypsum, that I'm hoping to work with going forward in the future, just because right now it's not the easiest thing in the world. It's not as accepted in the industry. It seems to be the atypical, and what I and others are hoping to do is to not only set up these pipelines and pilots, but to make it the typical, to make it the expected, and to really get the industry experience it needs to utilize these programs more.
Okay, well, I think that, so a whole bunch more questions came in, different variations on a couple things we've already talked about, but we could go a little deeper. So I think we'll hold those till the end. We are going to be hearing from manufacturers, their trade association anyway, here at the end about some of the practicalities and some of their thoughts and suggestions. So we will get that perspective. And I think, but in the middle, we're going to present or hear from David Drake, who is, I will introduce him in just a second, but we're going to hear about some research going on with being able to use gypsum wallboard waste to make a useful product. And so we're going to hear from David Drake. He's an assistant professor at Washington State University School of Design and Construction, where he co-directs the Reuse Design Laboratory, along with Professor Taiji Miyasaka. His current research is focused on development of novel high-performance building materials produced from low-value construction and demolition waste. This includes methods and mixtures for masonry construction blocks produced with drywall waste, and methods and mixture for fire protective thermal insulation, also made from drywall waste. Both technologies have patents have been filed for and are in process. So with that, I will turn it over to Professor Drake. And I'll get my camera off here and take it away.
Okay, Jennifer, are you seeing the first slide up? Let's see, is my microphone working?
Oops. Yes, it is.
Okay,
yes.
And is my first slide up?
Your first slide is up. Yep. And your camera's on, so we're seeing you too. Okay?
Great. Well, thank you for the introduction, Jennifer. I'll go ahead and also switch my video off here so you can see the slides as large as possible. Hopefully those are still up. So thank you, Jennifer, for the introduction. As you said, my colleague Taiji Miyasaka and I co-direct the Reuse Design Laboratory at Washington State University School of Design and Construction. Our lab focuses on developing new products and technologies made from low-value construction and demolition waste, and currently our focus is on gypsum drywall waste. So what I'll be presenting today is a brief overview of our lab's research and development regarding new applications for gypsum drywall waste. A bit of background, kind of a supplement to what Michael presented and what was presented at the webinar a couple of weeks ago. Gypsum drywall waste is a small but significant part of the growing global waste problem, much of which is due to unsustainable building practices. So globally, we see that about 93 billion tons of resources are extracted from the earth every year. Building needs alone account for about 41.8 billion tons of those resources. And of the total 93 billion tons of resources extracted, about 67.4 billion tons are dispersed to the environment as irrecoverable waste. Much of that irrecoverable waste is emitted as pollution, including carbon dioxide and other greenhouse gases, and a significant percentage of greenhouse gas emissions is due to manufacture of building materials, including concrete and concrete masonry, as well as plastic insulation foam and other insulation materials. So this construction and demolition waste accounts for about 23% of total waste in the United States. And in the United States alone, C&D waste has more than tripled during the past decade, and that was in spite of the 2008 global recession. Data shows that construction and demolition waste recycling provides many environmental and economic benefits. However, gypsum drywall waste is a low-value commodity with few current reuse and recycling applications, and a lack of applications for recycled drywall waste is a barrier to increased recycling. Consequently, most of this drywall waste, at least in areas where bans are not in place, is disposed of in landfills. What's the problem with that? Well, under landfill conditions, as we heard during the last webinar, Bacteria metabolize the drywall waste and produce hydrogen sulfide gas. At low levels, H2S is detectable as an offensive rotten egg odor and has health impacts at higher concentrations, amongst other issues. Production of a novel building material using drywall waste, gypsum drywall waste, has the potential, we think, to reduce or eliminate some of these problems. So currently, our lab has 2 building material technologies with published research results and pending patents, as well as other projects that are in earlier stages of development. What I'd like to talk about today are these 2 building material technologies that are the most advanced in our research pipeline. So first would be the drywall waste block technology. We call it DWB. We began trying to develop new applications for drywall waste about 6 years ago. And the first product was a masonry unit made from approximately 90% drywall waste and other waste materials. These blocks have been through a number of iterations as we've improved production methods and found other uses for the basic process that we use to make them. To create maximum impact, we focused on research objectives that lead to rapid commercialization, or we think will lead to rapid commercialization and scale up of the technology. For us, it's really important that the work we do advances beyond lab scale work as quickly as possible so that it actually has a chance to make an impact on the drywall waste problem rather than remaining in the lab. So those research objectives included developing a system that was agnostic to drywall types, that could use type X, that could use typical drywall, that was insensitive to the thickness of the drywall material, whether it contained fiberglass reinforcement as type X does, whether it had waterproofing paper layers as greenboard does. We wanted to make sure that our methods of processing the waste were as simple as possible. Typical recycling methods, as far as we know, currently require separation of the gypsum core from the paper outer layers. The methods we've developed, or the technologies we've developed, utilize what we call whole board recycling, where the waste is processed as an entire board and the paper and the core are both incorporated into the products. We wanted to reduce or eliminate Portland cement requirements whenever possible in our mixtures to lower the embodied carbon in the material. And we wanted to make sure as much as possible that the methods we were using were adaptable to industry standard manufacturing methods. So the process we've developed is relatively simple. The drywall waste blocks are produced using a low energy cold forming process. This is similar to processes used for manufacturing compressed earth blocks in the developing world. This turned out to be pretty effective for lab scale work. In the lab, we use pilot scale custom hydraulic presses with forming pressures and curing processes very similar to industry standard pressures and processes used in CMU manufacture. The block mixtures that we've developed incorporate, as I said, whole board shredded drywall waste, as well as waste-based cementitious binders. These blocks are formed at high pressure and cured and dried under ambient lab conditions. Low pressure steam curing, which is typical for CMU manufacture, is also possible with the materials and methods we've developed. And as you can see from this image, which shows our lab scale manufacturing, the mixture itself is quite dry. It's about the consistency of a damp soil.
I'm just going to cut in real quick. CMU, could you just define?
Oh, sure. Sorry about that. CMU, concrete masonry unit. That's the concrete block that most people are familiar with. They probably used to build bookshelves when they were in college, sometimes erroneously called cinder block. So, although drywall waste block production methods, the methods we've developed, should adapt easily to industrial manufacturing, and that would be regionally based manufacturing, The compact and portable equipment we use in our lab suggests that the blocks could also be produced and cured on site if that happened to be required. Work under development in our lab includes production and testing of wall sections using a self-aligning block system, similar to this illustration that I'm showing, as well as a panel system for interior partition walls optimized for acoustic performance. The initial testing in our lab has established the material's basic engineering properties, which are comparable to a number of load-bearing and non-load-bearing masonry construction materials like concrete masonry units. These results have been reported in peer-reviewed publication. At the end of this presentation, I have a link to our ResearchGate page, which has links to the peer-reviewed publications detailing some of this testing. So, for example, the comprehensive strength of the DWB, the drywall waste block units, is significantly higher than adobe blocks and autoclaved aerated concrete block, which is an insulated concrete block widely used in Europe. And the DWB units also approach the minimum strengths for concrete masonry units as established by ASTM standards. Most of the materials incorporated in the blocks we make are hydrophilic, including gypsum and paper waste, and this creates some challenges for use as an exterior load-bearing construction material. So while we've developed mixtures that contain additives that reduce water absorption to levels near ASTM standards for concrete masonry units, we have come to realize that interior non-load-bearing applications for our blocks likely have the easiest path to commercialization. Finally, the DWB density is lower and its insulative performance is much higher than conventional concrete masonry. This was investigated first through heat flow metering of DWB material samples, and then subsequently we tested insulative performance of a whole wall assembly using a hot box apparatus in our lab. For that, we built a single wide DWB wall using conventional Portland cement-based mortars and grouts with vertical reinforcing rod placed on code-required centers. The test runs were conducted at temperature differentials ranging from about 7 degrees C to about 20 degrees C. For the DWB wall assembly, maximum resistance to heat flow was found to occur at the maximum temperature differential between the hot and cold sides. We found that we were seeing insulation value approximately 4 times higher than the published values for an equivalent single wide CMU wall. That's using conventional Portland cement based grouts and mortars as well as steel reinforcing rod. By using DWB or drywall waste based grouts and mortars, which we've also developed, we think those values would be somewhat lower. So our conclusions with this research is that we've achieved performance that are beginning to approach the standard for concrete masonry units. We have mixtures and methods that reduce carbon footprint due to reduction and elimination of Portland cement. We're seeing superior compressive strength versus other insulated concrete systems, such as autoclaved aerated concrete. There are some technical gaps that remain with this process and this material, and it may be that investigating non-structural applications will help accelerate commercialization of the product. The non-structural applications we currently have under development include the following. We're looking at color variations through incorporation of powdered pigments, dyes, or waste paint, ornamental surfaces, which we form either by pressing with shaped dies or post-formation milling using CNC equipment, which would result in unique surfaces that could be created. And then we've also worked with a variety of consumer objects, including plant pots and other designs, and a waste-based alternative to so-called encaustic cement tiles, which is free from Portland cement and would be carbon neutral or even carbon sequestering in application. So in addition to this block technology, we've also developed a fire protective insulation foam made from drywall waste. The starting point for this research was an industry identified need for novel, cost-effective, non-combustible insulation materials. Typical foamed plastic rigid insulation panels are effective for reducing building heating and cooling loads, with consequent reductions in energy use and associated greenhouse gas emissions. However, plastic form manufacturing and in-service use results in significant greenhouse gas emissions. In addition, plastic foams are flammable and have been implicated in recent building fires. Combustion products of polyisocyanurate foams, including hydrogen cyanide, are especially concerning. There are non-combustible insulative building products. For example, as I mentioned earlier, autoclaved aerated concrete block and other foamed concrete materials have a long history of use with patents dating back to the 1920s. However, the thermal performance of foamed concrete is inferior to conventional insulation materials, and foamed concrete mixtures require significantly higher proportions of Portland cement than conventional concrete, and this all increases the material's carbon footprint. So what we've done with this drywall waste-based foam is we developed proof of concept drywall waste foam specimens through initial experimentation and qualitative assessment of those specimen properties. Schematically, drywall waste foam combines drywall waste and waste cellulose fiber with a liquid foam agent and a binder made from waste paint. These mixtures are then foamed through high-speed aeration with a wire whisk. We pour the foamed mixtures into burlap-lined wire mesh molds and cure and dry them for a minimum of 24 hours at relatively low temperatures. For testing, we then cut the cured and dried foam billets into specimens and calculate density from measured mass and volume. Imaging of the microstructure of the specimens reveals that this foamed material has an open cell fibrous matrix, and the cell size generally increases as the density decreases. Further investigation of drywall waste foam properties has included evaluation of the thermal conductivity using a commercial heat flow meter and evaluation of hardness using an apparatus designed and constructed following ASTM standard test methods for acoustical ceiling tile. We also evaluated friability using a method specified by the same standard. And then for evaluation of burn-through time, since we expect this material due to the gypsum content to be highly fire protective, we've developed an alternative test procedure due to the impracticality of lab scale investigations using ASTM standard test methods. Our test apparatus consists of a Bunsen burner, specimen support, a pyrometer, and a timer. We measure burn through by measuring the length of time required for the burner flame to penetrate the sample and ignite a cotton pad attached to the top surface of the specimen. To allow for comparison and account for potential inaccuracies resulting from the method, we have also evaluated specimens of analogous material alongside specimens of our foamed drywall waste panels. Those materials include expanded and extruded polystyrene foams, as well as acoustical ceiling tile. And due to the wide variation of units of measure and observed magnitudes across all of these evaluated properties, we assigned a standardized performance ranking, and that enables us to compare between the properties. This chart here gives some of those details. And we find from this that drywall waste foam compares favorably to other products and is superior in some respects. As with DWB, the block material, the next steps for this, for our research on the foam material, will include construction and testing of full-scale wall assemblies for insulation and acoustic properties. With the foam material, we conclude that this is a potential new application for a problematic construction and demolition waste material. We're hoping that it could replace, to some degree at least, carbon-intensive and flammable plastic foam insulations. We find that it has mechanical and insulative performance comparable to existing building materials, It's fire protective due to the nature of gypsum. Remaining challenges with this technology include quality control due to a range of variation in waste-based ingredients, and limited applications versus plastic foams due to the hydrophilic nature of gypsum and cellulose fiber. In other words, in practice, to utilize this material in buildings would require the same sort of detailing to keep water out of the assembly that you would expect with an insulation material like fiberglass or cellulose insulation, either dense pack or loose pack. So more information can be found both at our lab's website, which is the address above, and as I mentioned, those papers that have been published reporting the results of our preliminary investigations can be found on my ResearchGate profile page. Of course, anyone is welcome to email either Taiji, Miyasaka, or myself.
Great. Thank you so much, David. Very interesting. And let's see, there's definitely questions. Many people are wondering about the input. So is this just about the clean new construction scrap wallboard, or can you take demolition wallboard and renovation wallboard?
So that's the big question. I think it's probably the big question for any of the recycling methods. What we've tried to do throughout the research, in addition to making the products insensitive to types of wallboard, is to the extent that we can, we've tried to make sure that these methods can use demolition waste as easily as they can use clean construction scrap. I mean, that's assuming that the demolition waste is from installations that are recent enough that we don't have a risk of lead paint contamination or asbestos contamination. So pretty much anything from the 1990s on should be fine. As Michael indicated in his presentation, the cycle of renovation and commercial construction is quite short, from initial installation to the time the material would be torn out for renovation. And so we think that the chances of contaminated material in most of the demolition stream is fairly low. We have done tests in our lab with demolition material, and we don't see any significant difference between materials made with demo waste versus materials made with clean construction scrap.
Okay. People are wondering about air quality. Have you run some tests about air quality for these blocks in an indoor environment, or the insulation?
We haven't yet. That's one of the things that is on our list. We're fortunate enough as part of the Boylan College of Engineering and Architecture at Washington State University to have colleagues who do indoor air quality research. The Laboratory of Atmospheric Research, for example, has done quite a bit of work in that area. So that testing is something that we plan for the future. However, the ingredients that we're using in these mixtures are such that we don't expect there to be any indoor air quality issues. We're not using, for example, chemical binders that could potentially cause issues. We use waste-based cementitious binders, as well as this a high-pressure cold forming process.
And another question, so you showed us some fire tests with the foam insulation, but how about on the block? And particularly, someone's quoting ASTM E119, if you run that fire test.
So I should say that most of the testing we've done, first of all, our lab isn't a certified ASTM testing lab. Most of this testing is, to the extent possible, we follow ASTM standards, but most of the testing we're doing is to establish basic mechanical properties, and also for our own purposes, to design purposes, to be able to rapidly iterate the design and make improvements to it. If I recall, and perhaps this person could clarify, I think that standard is flame spread index, but I wouldn't swear to it. And the simple answer is the flame spread testing, ASTM testing, that requires fairly large facilities or a fairly large sort of fire tube assembly is not something that we have the space for. I can tell you that the blocks, just by taking a propane torch and holding the torch to a block or to the foam material for that matter, it is entirely non-combustible, as you would expect from the ingredients. It will neither sustain a flame nor burn through in any reasonable amount of time.
Okay, and then we'll take one last question, and then we'll get our next presenters and then have questions at the end. But can you just discuss briefly your thoughts about the commercialization process? I think for the blocks, you indicated people might be able to do them sort of on site or near where activity's happening. I don't know about the foam insulation, and just, yeah, what if someone was interested in trying to take this further, you know, like what's the steps?
So as university researchers, the commercialization process was a whole new crazy world for us. We're fortunate enough as researchers with the university to have the university's Office of Commercialization working with us on most of these issues, and we have a technology associate with the Office of Commercialization who handles most of the contact with industry and most of the intellectual property issues. What we've found in trying to move this towards commercialization is that process for a load-bearing construction material, a replacement for concrete masonry units, would be quite lengthy. The construction industry is very conservative when it comes to adopting new materials. Oftentimes, there's good reason for that conservatism, particularly when it comes to load-bearing exterior materials, where there's all kinds of potential issues. That's one of the reasons why the most recent commercialization grant that we're working with focused on interior non-load bearing applications, more ornamental applications. We are in conversations about licensing with organizations. I can't say much more than that. That process is fairly lengthy, and that, as researchers, that's the direction that we're interested in going, is licensing the technology to a manufacturer. Obviously, most of the work we're doing at the moment is pilot scale, I guess we'd say. We can produce full-size blocks, we can produce them in a reasonably short period of time, but we don't have anything like a commercial manufacturing facility. Commercial manufacturer, no doubt, would be making significant changes to the form factor of the material and probably to the production methods.
All right. Well, I think in the interest of time, we'll have to move on, but there's definitely questions, and I already have a question for Michael that's related to your project. So thank you so much, David. And we are going to move on now to our next presentation. So we've got two presenters from the Gypsum Association, which is a trade association. I'm sure they'll tell you a little more about it. So let's see, you should have gotten the thing up to share your screen. We've got Steve Meima. He has served as the executive director of the Gypsum Association since 2013. Let's see, you guys okay with getting your screen up? Yep, there we go. Great. So yeah, I just have to start the slideshow and start from the beginning, probably. Yeah, there we go. Perfect. Okay. He's enjoyed a professional career within the manufacturing realm. For the past 25 years, he's focused on building products and systems. He spent 13 years with the global building materials supplier Lafarge, where he was based in the gypsum and the cement divisions and fulfilled assignments serving other Lafarge businesses, including concrete products, ready-mix concrete, and aggregates. He holds an MBA and an accreditation in public relations and is a LEED certified green associate. Susan Hines has also worked with the design and construction industry for more than 20 years. She's held communication and information positions with the American Society of Landscape Architects, the Design Build Institute of America, and the landscape architecture firm Ohm Van Sweden and Associates. She joined the Gypsum Association in 2014 and currently serves as Director of Stewardship and External Affairs. She's got her Master of Arts in History from American University and is also a LEED certified green associate. So with that, take it away, Stephen and Susan.
All right, well, thank you, Jennifer. Thank you, Namoa. Thank you, Nurk. We don't often have an opportunity to speak on drywall recycling, so we appreciate the invitation to share our experience and perspective today. First, a little bit about the Gypsum Association. We were founded in 1930 in Chicago, relocated to the Silver Spring area in 1984, and that's where we are today. The Gypsum Association has 6 regular members and 1 associate members, and our 7 members collectively operate roughly 70 gypsum panel manufacturing plants across the US and Canada. Today, Susan and I will be speaking generally about our industry rather than specifically about any one member company or plant. Our vision is to ensure a future where gypsum products are recognized and relied upon as being essential to the health, safety, comfort, sustainability, and resilience of our buildings and quality of life. Chances are that most folks attending this webinar today are within only a few feet of a decoratively finished gypsum panel wall or ceiling. Now, the graphic on the right of this slide is our digital ad that targets the AEC community, again, architectural, engineering, and contractor community, to direct them to our website for resources specific to the overall use of gypsum panels.
What you're seeing here are our main areas of focus, and as Steve just mentioned, they are highly technical in nature and are aimed at the AEC community, which includes, everyone from architects through GCs, drywall hangers, and code officials. We publish 30 technical documents on the specification, installation, finishing, and overall use of gypsum panel products, and we provide, one-on-one technical support. We also represent the gypsum industry before the building code bodies in the United States and Canada. I'm not going to read all of these bullet points, but I did want to point out that to correct a previous presenter who referenced the gypsum lobby, we do not lobby. We do appear before standard setting organizations like ASTM and NFPA, et cetera. But basically, that's the extent of anything that could be construed as lobbying. The other thing that's really important on this slide is our long-time development and maintenance of industry life cycle resources. So product category rules, life cycle assessment, and environmental product declarations, because our work in that area really informs our approach to recycling.
And we are a team of 5 individuals. 4 of us are LEED credentialed. We're all long tenured in the building materials and construction industries. And we have a total of 104 years of building materials and construction experience.
I'm really grateful to earlier presenters today who actually spoke about the the performance role that gypsum panels play in the built environment. And number one is fire protection. All gypsum boards have fire resistance because gypsum, by its very nature, is 21% by weight chemically combined water, so that when it's exposed to high heat, as in the case of fire, it releases steam and does not burn. It is non-combustible. It also, of course, provides the smooth monolithic surface that's ideal for paint and wallpaper and contributes significantly to sound control. It's versatile, economical. It's very easy to install and repair compared with other products. And it really does have a long in-place service life of at least 60 years.
All right, now transitioning. Today we will look at disposal and recycling material flows, speak to gypsum industry recycling experience, discuss how stakeholder roles and responsibilities shift under recycling scenarios, note some caveats, challenge a few assumptions, and offer recommendations and considerations for future discussion. Now, the prior presentations have been informative, but largely focused on their own operations. We'll take a wider approach to the issue, all stakeholders and parts. We'll be speaking to our industry's experience, overall challenges, opportunities, and concluding with recommendations and considerations for the future. As the last group to present, we've had the privilege of seeing other groups' presentations. We will comment in response, making clear where we agree, where we disagree, and offering what we see as needed to best inform today's audience. We'll take a fairly high-level view of the gypsum wallboard recycling business ecosystem while trying to be sufficiently comprehensive. We want to look at the totality of the parts, pieces, and flows, the circuitry, if you will, and how they must work in concert in any given geography to achieve higher levels of gypsum recycling. So often we hear, we just have to do it. Let's just start doing it. In reality, the it is the totality of a very complex process comprised of many stakeholders, each of whom must make changes and investments in their operations that are not without risk. Again, not without risk. Added to that challenge, how the circuitry works inevitably varies by any defined geography or region. Even if stakeholders are aligned operationally and financially, then the environmental impacts of this alternative state must be compared to the current state to ensure the circuitry results in fewer environmental impacts rather than different or worse environmental impacts. Individual stakeholder goals cannot be achieved at the expense of the environment. So, for example, we have seen that decreased landfilling of drywall incurs increased emissions associated with transportation over significant distances.
Our first caveat, why we are not going to be discussing demo gypsum here, because we reject that as a potential recycled feedstock at this time. And I don't think I have to spend as much time on this slide because so many of these things have already been laid out by previous presenters. And essentially they are material product safety concerns, and they're shared not only by manufacturers, but also by recyclers. And there's the lead paint. There was the 2012 Chinese drywall. An issue which seems to be resolved, but there may be drywall like that out there and we cannot legally recycle it. Asbestos contamination has been referenced before. And then of course, there is always potential for litigation because of these concerns about contamination. We hope eventually that innovation will overcome this particular roadblock. And to that end, though, just to seek applications for demo now, the Gypsum Association is supporting a 2-year research program into the durability of concrete containing recycled gypsum feedstock. And that's taking place at Dalhousie University. And while it is not completed yet, it's looking good so far. Here, we're looking at issues that we see driving change at this moment in time, and this to some extent specifically around the landfill space constraints, an issue that is very, very important in the Northeast, where landfill capacity is being met and challenged. Gypsum fines, lots of presenters have talked a lot about gypsum fines. I think they're probably a problem everywhere and maybe even worthy of addressing outside of a recycling scenario. And of course, landfill gas specifically hydrogen sulfide gas, which is not a greenhouse gas, but is very problematic, I could say almost everywhere. Now, the direction that things are going of note is, of course, this emphasis on job site separation and segregation. And I think that's one of the most important shared concerns that everybody has, because it's not a concern just for recyclers, but also for manufacturers who would be receiving that post-consumer recycled feedstock. Scrap management and handling, we need to manage clean scrap and demo panels through to ultimate recovery. And of course, fines diminish the amount of other streams that can be recycled. Landfill diversion, circularity is where we're driving toward. Closed loop, but also open loop, so secondary markets other than gypsum wallboard. And often that is being encouraged these days through mandates around higher percentages of post-consumer recycled PCR content rates. Now, in terms of recycling programs, what we're seeing as we monitor are voluntary industry stewardship programs, but also legislatively mandated programs. And often that takes the form of an extended producer responsibility program or a producer responsibility organization. We're seeing more of that. So obviously we are all reacting to these pressures in different ways, and we are seeking solutions for diversion and recycling.
And Susan, I'll just add that, and most people aren't aware, but gypsum board continues to be imported from upwards of 20 foreign countries to this day. In comparatively small percentages, but nonetheless, material does flow into the U.S. and Canada, and we're not aware of any oversight or regulation or inspection to confirm its conformance to standards. And I just want to put that out there, make that clear.
Thanks, Steve.
Now, this slide might be a little dizzying, but it's really the when we took a look at, either kind of the previous, current, existing, and former states, it's really a collection of the circuits to a gypsum panel manufacturing use, end of life, disposal, reuse ecosystem, if you will. It's the pieces, the parts, the flows, and we need to understand what makes each work. What can impede function among these parts? So the challenges associated with any given part of the system can be different and unique from another part. This was illustrated in each previous presenter's presentation. Capacity challenges, permitting challenges, economic challenges, end market challenges, operational challenges, and so forth. Recycling is about understanding or demystifying material flows in order to understand the economic impacts of the flows or flow scenarios and the environmental impacts as compared to, again, a current or baseline state. Think about it. Flow scenarios can be endless. Until you define a particular recycling region or territory, can you begin to isolate and study the elements of what is going on and the implications of what will change if aspiring to implement a recycling program. Satisfying the economic requirements of the stakeholders and achieving defined environmental benefits shouldn't be mutually exclusive. However, achieving both is no less than a big challenge. And so, this is the totality of the parts on this slide. On one end of the continuum, you could look at kind of the traditional flow where material flows from the gypsum panel manufacturer to the consumer, the project site. And again, the project owner, whether it's commercial or residential, is the consumer. They're the driver of demand. They're the driver of use. They're the driver of waste. And we need to acknowledge that. Now, that flow traditionally might go to the hauler and then to the landfill. The other end of the continuum would be that it flows to a processor where it serves closed loop needs or open loop requirements, as are illustrated here. Today, we're somewhere on the continuum. And that, of course, varies by region or geography. But I think, to date, we've looked at, we've seen a lot of very good presentations, but they focused on, a singular operation and the pain point in that operation. What we want to do today is kind of, take a high level view of what could be an ecosystem. And so, having looked at the parts and pieces, let's just look at the stakeholder. And again, we're not recycling experts here, but we are increasingly looking at the state of affairs. And so we've inventoried the stakeholders. Perhaps there are others, but these are the stakeholders that rise to the surface. And what we have to consider in a future state scenario. What the stakeholders might have to concede and adjust to. Well, on the gypsum panel manufacturer's side, they may have to consider accepting more post-consumer recycled feedstock into their manufacturing processes, and certainly some are today, but the product must meet performance criteria, especially fire resistance requirements. On the project owner side, general contractors or project owners might have to, compensate general contractors or subcontractors more to source separate, so that clean scrap cutoffs, can be segregated at the job site. But these ought to be outlined in bid specs and contract documents. Important to note that on the contractor side, they're going to have to ensure that such requirements are built into the scope of services. They're going to have to train their workers to source separate. Haulers may have to consider new hauling requirements in order to protect the product as it moves on to the C&D processor or transfer station. C&D processors and transfer stations are going to have to accept, segregate, and manage material in new ways. And then gypsum scrap processors, well, they're going to be competing against landfills, and they'll have to take into consideration gate fees versus landfill tipping fees and so forth, so that there's an incentive. There's a business argument, but also an incentive for material to flow to their facilities. And governments, local governments, will have to consider creating regulatory environments where that prioritizes and incentivizes recycling. We've seen in our study areas where tipping fees have been increased to disincentivize waste material going to landfills. Consumers, well, we see with other programs that consumers have to pay an enhanced amount or fee in order to support, recycling programs. So these are things to consider, across the stakeholder continuum. And, but remember, the economic disincentives for most, if not all, of these stakeholders must be minimal.
So the gypsum industry has its own experiences with recycling, and much of that dates back decades internally. So at the plant level, manufacturers have used and manufactured recycled paper faces for decades, and they are longtime recyclers of their own waste, scrap, and dunnage. Of course, it's a lot easier to control your internal operations, and in terms of external experience, not all of it has been completely positive. So, for example, in Massachusetts, which banned landfilling clean scrap in 2011, in 2006, a recycler, gypsum recycler located in the Boston area, and two manufacturers agreed to purchase PCR feedstock, but unfortunately, not enough clean scrap was delivered to the processing facility to provide a consistent stream of post-consumer gypsum feedstock to manufacturers. So ultimately, the gypsum recycler went out of business. And it was attributed to basically landfilling outside of the state. So it was cheaper, or supposedly, for haulers and building owners to dump their waste in a state like Pennsylvania than it was for them to offload it, and probably easier. It was the status quo, and they were used to that, than to deliver it to the gypsum recycler. So I cannot emphasize enough how important consistent volume is to any manufacturer, and it's been a real pinch point when it comes to recycling. In Colorado, there was a request that a manufacturer engage in recycling clean scrap, and the manufacturer purchased the equipment for processing. And again, the volume of clean scrap that showed up was very low. And as a result, the equipment was idle. I mean, this is not something that you invest in and maintain in order to use once you have a decent sized pile of clean scrap. I mean, that's not efficient in manufacturing. And then finally, many of our member company manufacturers participated in building product ecosystem pilots. And those pilots really focused on sort of proof in concept in terms of like, can clean scrap be collected and segregated and sent to recycling? And those were based mostly in the New York metropolitan area and in Northern California and the Bay Area. But unfortunately, the so-called pilot didn't collect any data to attest to its success. So we didn't know how much contamination there was, what were the contamination rates, what were the environmental impacts, how far did that gypsum have to travel? And all that remained unknown. And that was a bit unfortunate because shortly after the completion of many of these pilots, we had to engage with the state of California in order to explore a potential recycling scenario. In 2019, 2020, some of you may be familiar with this, the governor and the legislature of California established the California Statewide Commission on Recycling Markets and Curbside Recycling. And they were charged with tackling and looking at and trying to solve vast problems across multiple waste streams. When it came to gypsum wallboard, the approach that they decided to take initially in order to reduce landfilling of gypsum waste was to mandate that boards sold in California contain post-consumer recycled content in escalating percentages over the course of numerous years. So that was their strategy to avoid landfilling at least clean scrap. And eventually, it was very ambitious and actually looked toward demolition waste eventually. Well, we were very concerned about that scenario, and we worked closely with the commission for 6 months, where they were trying to pressure the gypsum industry to establish just sort of a baseline. Okay, we will take back and incorporate X percentage of clean scrap waste. But the industry was very reluctant to commit to any percentage of post-consumer recycled content because they were concerned that volumes would not show up, and then they would be left in the lurch. You can't reach a commitment, you can't make good on your commitment if you do not know you are going to have the appropriate volumes. And given that there was not a single processor capable of producing clean scrap post-consumer recycled gypsum feedstock in the entire state, it made us even more uncomfortable because not every gypsum facility is capable of recycling at scale. So we were